Chapter 8, Section 2 and 3 go together, and it's all about different properties of the inverses. So the first thing we're going to do today is find the inverse, okay? And here's the steps you're going to follow. The important part I want you to note here is the new notation, okay? So F inverse, or F to the negative 1, means to find the inverse, okay? So to the negative 1 power means the inverse. So that's kind of your new notation. So we'll take a look at our first example. We've got y equals 4x plus 9, and the first part says find f to the negative 1. So this means find the inverse. Okay, so I'm just going to follow my directions. It says step 1, change f of x to y. In this example, we don't have an f of x, so we're just going to move on to step 2, which says switch x and y. So I'm going to go ahead and write x equals 4y plus 9. So you just switch your x and y. Step 3 says to solve for y. So the first thing I would do is subtract 9 from each side. And then to get y by itself, I would divide each side by 4. So I would get y equal x minus 9 all divided by 4. And then step 4 says change y to f inverse. So then put it in function notation. So f to the negative 1 of x equals x minus 9 all over 4. Okay, so my inverse here is x minus 9 over 4. Okay, so part B says find f inverse of 10. So just like we learned yesterday, that just means take whatever is in this parentheses and plug it in for x. So I've got 10 minus 9 over 4, so that gives me a 1/4. Okay, part C is a little trickier, so this is where we worked on yesterday, the composition of two functions. So if you remember from yesterday, we're always going to start on the inside function or the one on the right. So this one says find f of 5. Well, f of 5 would be your original one, which is the 4x plus 9. So that will give me 4 times 5 plus 9, which gives me 29. Now the composition says take that and plug it into the inverse. So now I have to find f inverse of 29, which is my yellow function. So 29 minus 9 over 4 gives me 20 over 4, which gives me a final answer of 5. Okay, well that should seem kind of strange because we started with 5 and we ended with 5. Okay, that is always going to be true. So if you can remember that the inverses cancel each other out, you could have gotten 5 from the start. Okay, so it's kind of a tip or trick here. The inverses cancel each other out, so you can just get the number left on the inside. If you don't forget, it shouldn't take you too long to compute those, but it is a shortcut for you. Okay, part D says, is the inverse a function? Okay, well, what we want to be able to do is look at the original. Okay, look at the graph of the original. Okay, so graph the original. Okay, and the original graph is 4x plus 9, and hopefully you can tell me that that is a diagonal line. Okay, if you can't remember, you can go ahead and graph that in your calculator. Now, to see if the inverse is a function, we are going to use the horizontal line test. Okay, so we have learned about the vertical line test before. Okay, and the vertical line test tested the original. But now we're talking about the inverses, so we're going to flip it. So this time, we're going to imagine that we draw a horizontal line, okay, through our function, okay? If it were to intersect our function more than once at any time, it would not be a function. Since no matter where I move my horizontal line here, okay, it's only going to hit my graph once. So that means this one passes. So is the inverse a function? Yes, because it passes the horizontal line test. Okay, so we're going to kind of just again imagine a horizontal line, okay, and if it only hits that graph once, it's a pass. Anything more than once would be a fail. Okay, and then we're going to ask one other type of question here, okay, and that's going to be to prove our answer. Okay, so prove that it's an inverse. Well, we have seen inverses before. You kind of know the inverse of 1/3 would be 3. Well, if you multiply those together, you'll get 1, okay, or in effect, they cancel out. So what you're going to do is prove that if you multiply yours together, okay, that they cancel out. So the first thing you're going to do is find f of f inverse of x. Okay, so you're going to compose them together to see if they cancel out. Now, if they really do cancel out, we're just going to be left with x. So start with the one on the right. Okay, so that's the inverse, and our inverse was x minus 9 over 4. Okay, so you have to take that and plug it into our original. And remember, you always plug it into x. So when I plug that into the original, I have 4 times x, which is now that whole huge thing, and then plus 9. Okay, now watch your steps here. What would cancel first? Well, 4 times 1/4 here would cancel. Okay, so my next step would say, okay, now I've got x minus 9 and then plus 9. Well, obviously the 9s will cancel, so here I'm just left with x. And then I usually just put a smiley face because that's what I'm looking for. Okay, now be really careful. I need to see all of those steps in the correct order for you to get full credit. So make sure you're crossing them off in the correct order. Okay, well, it's not just enough to prove it that way. We also have to say that if we were to plug it in the other way, so f inverse of f of x, that we still get x. So this time, I'm going to start with my inside function, which is 4x plus 9, and I'm going to plug it in to my inverse. Well, my inverse says x, but now it's 4x plus 9, and then it says minus 9 all over 4. Okay, now careful with your orders of operation. This time, your 9s cancel first, okay, because it's all in the top part of our fraction, leaving me with 4x over 4, and then my 4's cancel to give me x, okay? 90% of the time, these two steps here are going to cancel in different ways, okay? So if you cancel them out all at once, you don't get credit, and if you cancel them out in the wrong way, you don't get credit. So make sure you're doing your orders of operation here and canceling them out appropriately. Okay, so that's all the different kinds of questions you're going to see. So let's see if we can try some more. Okay, so step A and example B says to find the inverse. Okay, so first step there is to switch your x and y. Okay, and then solve for y. So I will subtract 1 first. Okay, and then to get rid of a third power, okay, I'm going to take the third root. Okay, because that'll cancel it. Awesome. So then I'll relabel it f inverse of x will equal the third root of x minus 1. Okay, you could also write that as x minus 1 to the power of 1/3. Whichever one, you know, seems to make more sense in your brain is just fine. Okay, so instead of getting rid of a square when we would square root it, to get rid of the third, we would third root it. Okay, either one is fine. Okay, part B, find f inverse of f of -2. Well, I know that the inverses cancel, so this just equals 2. Well, that's kind of nice. Part C, is the inverse a function? Okay, so is it a function means we're going to use that horizontal line test, which meant I needed to graph the original. Okay, make sure you are always graphing the original. So the original was x to the third plus 1. Okay, you could go ahead and graph it in your calculator, and you should get a graph that looks like this. Okay, so now I'm going to go ahead and draw a horizontal line through there. Okay, and then I'm going to see if at any point, if I move that line, okay, is it going to, oopsies, it's not moving for me anymore, but if I were to move this graph anymore, okay, it would only hit it once. So this is going to be a yes, it is a function, because it passes the horizontal line test. Okay, so let's try another example. Part C, f of x equals 8 divided by x. So find f inverse. Okay, so here's the first example where you actually have to do the first step, which is to cross off the left side and make it a y. So just remember those are different notations and you can just interchange them however you need to. So now that I've crossed that off, now I'm going to change it. So it's going to say x equals 8 divided by y. Now I have to get y by itself, and this is a little trickier because y is on the bottom of a fraction. So what I'm going to do is I'm going to put x over 1, okay, and then I'm going to cross multiply. When I cross multiply, I get xy to equal 8. And then to get y by itself, I would divide by x. So my f inverse of x here happens to be 8 over x, which is the same, exact identical to the original, okay? And that happens sometimes, and it's fine. Okay, but now I want to prove it, so I want to see if I can prove my work. So f inverse of f of x, okay, proving it is where you want to show that they cross out. So I'll make little notes here so we can remember that, show that they cross out and equal x. Okay, so f inverse of f of x means I would start on the inside here. So I want to take f of x, my original, and plug it into the inverse. So the inverse is 8 over x, but x is now 8 over x. Well, this looks fun. So hopefully we can remember some of our algebra, where when you remember that when you're dividing fractions, you can really multiply by the reciprocal. So this is really 8 times x over 8. Okay, so the reciprocal of the bottom. And then remember, when you multiply fractions, you multiply straight across. So that gives me 8x over 8. And then from there, the 8's cancel, so we equal x. Okay, now because this case is special, the inverse and themselves are identical. We do not have to do it the other way because it will look identical to that. Okay, so that this is a special case where we only do it once. Okay, so let's take a look at example D. And example D doesn't give us an equation. This time it gives us a set of ordered pairs. And we can do the same thing. Okay, it's just a little different. So this one asks us of the domain. And hopefully you remember from semester 1 that domain is the x's. And in a list of numbers, we're going to list our x coordinates in increasing order. So 1, 2, 4 is our domain. And our range will be the y values. So our y values in increasing order here is 1, 3, 4, and 5. Okay. Then step 3 says to find f inverse. Well, that's a little trickier because we don't have a, well, we do have an x and y, right? It's just in an ordered pair. So the first thing we're going to do is switch them. Okay, so instead of 4, 1, I'm going to have 1, 4. Instead of 2, 3, I'll have 3, 2. Instead of 1, 5, I'll have 5, 1. And then 4, 4 will stay the same. Okay, so the inverse here just means switch x and y. Okay, so flip your ordered pairs there. Okay, well now here's where it gets a little interesting. Well, what is the domain of our new one? Okay, so if we look at example C, the domain there is the x's. The x's are now 1, 3, 4, 5. And the domain, I'm sorry, the range now is 1, 2, 4. Well, what really happened here? Well, I can maybe give you a little clue. These two look the same, which is the domain and then the range. And then the range and the domain are also the same, but they flip-flopped. Well, that should make sense because our x and y flip-flopped. And that's always going to be true. So the domain of the original is always the range of the inverse. And vice versa, the range of the original is always the domain of the inverse. Okay, and that will be helpful as we move forward, but this is something that will always be true, so you can use that to help you as you move along. Okay, so wise people never stop learning. Okay, there was a lot of things that happened there. I'm sure you've got a question. Write one down, bring that to class tomorrow, and we will go over it. Okay, good job.